Hi, Henk Akkermans here. Supply Network Dynamics Chapter 2, Part 7 I think. Causal loop diagramming. Causal loop diagrams are very convenient in two stages of the modeling process. At the beginning and at the end. At the end is the orthodox use of them and the way in which we will be using them most of the time in this course. Models can become pretty big and you'll see that over the coming weeks as well. And yet their behavior can usually be characterized by just a few loops, 2, 3, 4 loops. That's usually all you need to explain why the model behaves the way it does, even though there may be hundreds of variables in them and hundreds or more loops connecting all those variables. And that's the way that Jay Forrester, who originally developed system dynamics, used causal loop diagrams to explain the main driving forces in the model. Personally, but not just me, but thousands of people have also found causal loop diagramming very helpful in the beginning of a system dynamics modeling process, because it's helpful to summarize visually the different theories, different ideas that people may have about why something is happening, what is causing something, where does that lead to. That's more the messy front side of model building, and there it's useful for as well. In this course we won't be using causal loop diagramming in that way, but I strongly encourage you to do so in your own efforts to understand this complex world of ours. Anyway, the syntax is fairly straightforward. You've got words, variables, and you've got arrows between them. And those arrows can have two signs that can be positive and negative. If the sign between birth rate and population is positive, that means that more births will lead to a bigger population. If actually you think that's a positive thing, strongly depends on your views on population and on births in general. So the number of child molesters on the street and the number of children molested may be a positive relation, doesn't mean it has to be a positive thing. Those two different meanings of the word positive you should distinguish clearly here. So this is called the polarity of the link, can only be plus or minus. And in the middle you see these R's and these B's, so they summarize the overall, those loop identifiers. They identify that there's a loop, but they also identify if that loop is positive or negative. Positive and negative can be confusing because you also have pluses and minuses at the arrows. So usually in this book I use the term R or B. R stands then for reinforcing feedback, B stands for balancing feedback. If a loop is positive or negative overall depends on the number of pluses and minuses. If there is only pluses, it's of course a positive loop. If there are pluses and minuses, it depends if the number of minuses is even or uneven, because minus times minus becomes plus, as you learned somewhere at the age of 11 or so. And what you can also do is walk through the logic in a model. Okay, get more children born, more population, so more adults that can create more children, so more children born. So walk your way, this is trivial, but walk your way through the logic and see what you end up with. Suppose that this goes up, what then goes down? Causal loop diagrams, causal loops have a very nice way of summarizing the interaction between structure and behavior. So what's first, the chicken or the egg? Well, the system dynamics perspective on it is there is nothing first. They're interconnected. Notice that I have a plus here rather than the R that would happen more often. So this is a structure, a causal structure. There is a behavior associated with this, and that's exponential growth. The more chicken, the more eggs, the more eggs, the more chicken. The real world is a bit more complex. The more chicken there are, unfortunately, the more likely they are to cross the road. And you know, those roads of nowadays, they kill chicken. Without the eggs, there will be fewer and fewer chicken left. Of course, initially, lots of them would perish along the road, gradually fewer and fewer of them. So that's clear enough, but the combination of this reinforcing and this balancing loop already becomes quite complex. It's probably some kind of S-shaped growth, but it may be different after all.